For number 5, it says graph the equation in standard form. So I need to do the cover-up method. So to find the x, I cover up the y, and we say that this is 3x equals 12. So to solve, I would divide by 3. 12 divided by 3 is 4. So I put a point at the 4 on the x-axis. Then I cover up the x, and I would have 6y equals 12. So if I divide by 6, we get y is 2. So again, the y-axis, put a point at 2. Then we just connect those 2 points to get the line. Okay, in number 6, we have an inequality. So this is in slope-intercept form. So first, this is your slope, which is a 1. And I'm going to put that over 1 for m. And then b is 5. So I would have to rise 1 and run 1. And then I can do the opposite, going down 1, left 1. And I just do that several times until I reach the end of the graph. Now we have a greater than or equal to. So greater than or equal to means that you have a solid line, and we are shading up for greater. So I draw my line, and then this is where I began my graph, and I go up. So this part of the graph is what would be shaded. For number 7, write an equation in point-slope form of the line containing the points -11, 2 and -12, 7. Then transform that equation into to slope-intercept form. So 1, I would want to label this x1, y1, and then x2, y2. I have the y1 and I have the x1, but I was not given my slope. So I have to find that. So I'm going to use this formula, which is given to you on the test, and I'm going to plug it in. So y2 is 7, y1 is 2, x2 is -12, and x1 is a -11. So this becomes a plus. 7 minus 2 is 5, and then -12 plus 11 is -1. So if I divide that, we get that m is -5. So now I have m. Again, I have that x1 and y1 over here, and we're going to plug these 3 numbers into point-slope form. So y minus 2, m is -5, and then x minus a -11. Okay, this becomes a positive. Then I need to transform it, so I want to go ahead and distribute my -5. So -5 times x is -5x. -5 times 11 is -55. Then I add the 2 to get the y by itself. And then that becomes -53. Okay, and then for the last 3 on this page, this has to do with exponents. So I'm going to take the 2, because I have the parentheses, I'm going to distribute that 2 to the 7 and the -9. So I have 14, and then I have y to the -18th, but I can't leave it negative, so I put the whole expression over 1, making it a fraction. So the x to the 14th stays where it is. It's positive exponent. The y, however, will move to the bottom and become a positive exponent. In number 9, we have a fraction here. So what we will do is we will subtract exponents that have the same base. So x and x, I can subtract 8 and 3. Then the y's, I can subtract the 10 and 2. And then for the z's, 7/8 minus 1/8 is 6/8. Remember, you just subtract the numerators. You leave the 8 or the denominator the same. But on this problem, I would have to reduce this. So I can leave it x to the 5th, y to the 8th, and z. These two numbers are divisible by 2. So 6 divided by 2 is 3, and 8 divided by 2 is 4, so that reduces to 3/4. Okay, and then lastly, for this page, we've got -1, 0, 1. Remember, we used the 3 numbers in the dead center of the graph, and I plug them into the expression. So 3 times 3 to the -1 power. And then you apply the exponent rules you've learned. So this will have to go to the bottom of the fraction. 3 to the 1st is just 3. And 3 divided by 3 is 1. Then I have to plug in the 0. So 3 times 3 to the 0. 3 to the 0 is 1. So 3 times 1 is 3. And then the 1, I got to plug it in. So 3 times 3 to the 1st power. 3 to the 1st is 3. And 3 times 3 is 9. So now I just need to plot these points. So the first one, -1, 1. 0, 3. And then 1, 9. We draw the curve, and we get really close to x, but again, we don't actually touch the x-axis.